Hello and welcome to this week's What Were They Thinking? Amongst the many news items we have for you this week is the descent into the madness of homeopathy by doctors who were prescribing ivermectin for COVID, mistakenly anyway. Further evidence of the long-term effects that mass diseases have had on natural selection and therefore humanity from further back in our own development as a species. Difference in brain structure for left-handed versus right-handed individuals leads to changes in how creative they can be. Kenya is in a precarious situation as arguments spread throughout the government and population about the use of genetically modified crops, given that most of their crops are failing spectacularly. Hummingbird-sized ant fossils have been found, and this has overturned much of our understanding about just how big they can get. Yet more uncomfortably sized spiders have been found, and they are, inevitably, causing everybody to throw a fit. Finally, whales, specifically orcas, are killing sharks, many sharks in one video. The timestamps for these and other news items can be found in the description box below. Let's start with Dr. Tess Laurie. She is a prominent figure, let's say, in the anti-vaccine and pseudoscience community. They were promoting ivermectin. This was for COVID-19. As has been established, ivermectin does not work for COVID-19. There is no reliable, consistent clinical evidence to support its use. It does not work. Despite this, and the obvious clinical evidence, they've continued to try and prescribe it. Or at least they've been promoting it. Whether or not they prescribe it for COVID-19 or off-label is a different matter. They then extended this to treating cancer, for which ivermectin has no known uses at this point in time. Given that they're already well established at making up treatments, they've decided to go all in for homeopathy, and they're using that as another treatment. Homeopathy, as we have demonstrated, has no benefit. The reality is, once you get to the concentrations most homeopaths prescribe, you would be lucky to find a single molecule of the active ingredient in an entire ocean's worth of it. That's how little is left. You would think someone medically trained could at least appreciate that homeopathy will do nothing for COVID-19, let alone long COVID. Yet for some reason, not only have they gone with the pseudoscience and quackery of ivermectin, they've then extended this to inappropriate diseases like cancer. Now they've gone with the completely crazy and utterly nonsensical use of homeopathy to treat it, which has even less foundation to its use than ivermectin could arguably have, in that you could say that there is some vague out there chance because it's at least something, versus having a placebo. Frankly, given how the article descends into the activities that this homeopath has been up to in giving treatments to autistic children and children with ADHD, claiming that it improved their outcomes, we were just too frustrated to get any further into reading it. But you'll find the full article linked in the description box below, where if you can get through the initial nonsense of having prescribed inappropriate treatments, you may also find yourself just as flustered as we are, but they at least substantiate the evidence provided. This is something that homeopathy can rarely, if ever, do except as anecdotes. Most science, and for that matter clinical practice, relies on more data-driven ways to prove what's going on. That is clinical evidence, and it means you have evidence-based medicine. As far as archaeology goes, this is often in physical remains left behind, whether they are goods, items, and structures, or in some cases the actual remains of individuals. This is where research looking at the prevalence and impact of Yersinia pestis, or the Black Plague cause, has indicated it led to widespread genetic changes and basically a evolutionary pressure to select for these particular traits, and that those traits are now showing up as a result in modern humans, and this is therefore affecting our immune system in interesting ways. The gene we're talking about in particular is called ERAP2. If you had this gene, you had a about 50% higher chance of surviving. Well, specifically, if you had 2 copies of the same gene, as each of your parents may have given you a different version. If they were different, you didn't have that advantage. This was identified by looking through datasets, and particularly useful datasets that are increasingly being used for research, these being the UK Biobank, FinGen, and Genomic. These databases have hundreds of thousands of datasets from individuals that you can look through and try and find if there is patterns that are relevant. Why we say this has particular relevance to the modern humans and not just the survival of individuals exposed to Black Death is how it plays out in the modern diseases that we're particularly aware of at the moment. For example, COVID. It seems that having the double copy of the alleles that are responsible for this meant that you were more protected against respiratory diseases, which was one way to spread Black Death, but it also gave you an increased risk of autoimmune disease. This boils down to how that gene tends to break up the proteins in something that would be considered a pathogen by the immune system, and means the immune system can then begin to attack it more effectively. It would therefore indicate that somehow the body loses some of its sensitivity to self through this different allele, and is therefore less able to identify itself, and therefore you develop autoimmune diseases or immune diseases that don't recognize your own body. This would also have the interesting effect, at least from a environmental selection point of view, that given that we almost never have to worry about Black Death today, this is actually a disadvantageous development, and so those individuals who have different versions of the allele are more likely to have fewer issues as a consequence, and therefore be more likely to reproduce. Therefore, they are more fit for their environment. Of course, if we ever encounter another large-scale disease outbreak like Black Death, it might come in handy once more, but that's some of the way that evolution works. It's an ebb and flow of different phenomena, or pressures, tend to put different advantages or disadvantages on different mutations, and so you will see change over time as the world changes around us. Beyond the immediate medical developments this week, there is also an interesting psychological investigation of optical illusions of a kind and how autistic children tend to see them somewhat differently, particularly this example here. This image is seen a number of different ways, either 2 faces looking at each other, a vase, or something similar. But this doesn't necessarily mean that's what everybody will see. And that's how autistic individuals seem to have a different way of processing the image. Of course, just one image really wouldn't prove anything, so they've relied on a number of different optical illusions and scanning of the brain to figure out what's going on. They used 60 children and just under half had autism spectrum disorders. They then presented them with a number of different illusions to see how their brain would deal with this. The idea was to figure out, is it a difference in how the brain processes it, where it processes it, or whether or not there are differences in where and how the brain communicates within itself, and that this would or would not then help better understand the neurobiology and, to a certain extent, neuropathology of autism. Skipping over the methodology section, other than to say that they found a way to make sure that the people involved weren't trying to solve the image or focus on it, the autistic individuals involved had a greater delay in the time taken to recognize that there was a shape involved in the way the illusion showed than individuals without, and that this was indicative of a very different way of processing the image in their brains. While this is not immediately useful, it could lead into pathways that would allow psychologists and counselors to develop better techniques that would support the behavioral changes and adaptations that autistic children would find advantageous in their life. This contrasts significantly to, say, left-handedness. Whilst yes, you will have the unfortunate reality of winding up with ink spread all over your left hand unless you hold the pen in an incredibly awkward way, or write in reverse like Leonardo da Vinci, you otherwise have very few inconveniences. There are, however, some advantages that are less obvious until relatively recently, and certainly not well established with evidence. This includes that you are more creative, it would seem. The basis for this is at least partially driven by the fact that left-handed individuals don't have the same degree of brain lateralization or equal division between the left and right hemispheres. This means you don't get that kind of specialization that you might otherwise see in a right-handed individual, which is something of an interesting anomaly. The neurology aside, there's also a possible more practical answer as to why left-handed individuals are more creative, and that is simply they need to adapt to a world made for right-handed individuals, and as a result they're constantly finding creative alternatives. Going from neurological news to more, let's say, mundane news, and specifically that although caffeine may be good for you in reducing your heart risk, as we noted last week for the elderly, it may not necessarily be good for you if you have hypertension. This also shouldn't be very surprising news. Hypertension is blood pressure above 120 mm mercury for systolic and above 90 for diastolic. That's about the right ballpark for being healthy. Anything above that is hypertension. Anything below that, and you're not necessarily unhealthy, but you may be hypotensive or low blood pressure. Caffeine is a stimulant that will increase heart rate and therefore increase blood pressure. This is fine for people who have normal blood pressure or who are hypotensive, but if you're hypertensive or too much blood pressure, increasing that further could cause harm. Simply put, it's like blowing up a balloon even more when it's already under pressure. Most of the time it'll be fine, but occasionally it will be too much and the balloon will burst. This is why a lot of research needs to be taken in a very narrow context. If you're healthy and otherwise normal as far as your cardiovascular concerns go, caffeine is fine and may be beneficial. It could also provide protection for other risk factors like liver disease. If you're not, then it could be dangerous. And that's one of the quirks with the papers mentioned in the Skeptical Raptor publication here. That is that their research, as they point out, doesn't necessarily apply to everybody in every way. And this is also where we find a changing landscape as new research emerges, new things have to be identified, and that they may conflict with prior research until you figure out what is causing that conflict. Humans are complicated, they are messy, and they can often be difficult to figure out what's going on, especially if you are not doing your research in a very controlled setting. A lot of people involved in surveys, for instance, will do one of two things. Either report what they think the researchers want to see, or try and present what they're doing in the best possible light, even if that means fudging numbers. This is also where the study has a problem. It relies heavily on self-reported data, and unfortunately, that's where you're going to have a hiccup. As mentioned, self-reporting is generally one of the more flawed issues you'll find in research. As a method goes, it's okay, but you need to then back that up with something far more reliable. This is the same issue that we also find this week from another article by the Skeptical Raptor website about artificial sweeteners and post-meal hormones. These are what will tell your body whether or not you are still hungry or if you're finally satiated. The systematic review and meta-analyses were conducted to try and figure out just what's going on with all of this research. And although it is an extensive publication, we'll give you the short version here, and if you're so inclined, you are able to access it yourself and read through it. Or go to the Skeptical Raptor website, and their article does give a good deal more information than we can provide in a summary video. The very brief summary of it is that drinking a artificially sweetened beverage did not make you hungrier, but also didn't affect any of the hormones circulating around in the body. Further, drinking a beverage that used a sugar-based sweetener that was digestible by the human body, therefore calories, raised blood glucose levels, which is what it's meant to do, but it didn't have the desired effect on hormones that would indicate hunger. This meant that people would still want to eat something even though they had had their calorie intake satisfied by drinking something like Coca-Cola. As an interesting additional point to this, they did find that artificially sweetened beverages basically had the same effect on the human body as drinking water would in terms of the hormones being passed around the body 2 hours after consumption. Same thing with blood glucose levels. So that means it's really no different than consuming water in terms of the effect it has on the way the body recognizes whether or not it is or is not hungry. On the topic of food though, we can shift to Kenya, and Kenya is yet again facing massive issues with crop failure. It's not a country that is necessarily hospitable to human habitation, and this has led to many years where they've had problems with getting food. This has led to both internal stability issues along with food stability issues. They rely on what you could consider traditional crops, notably corn, but corn varieties that have not been genetically modified, and this is something that is not doing them any favors. A genetically modified crop can be made to, for instance, be more drought resistant, produce its own pesticides, or more. This is why the farmers and public are pushing for GMOs to be approved in the country. In the middle of their worst drought in decades, they have no water available for irrigation, let alone for people in many cases, and as such, they don't have food. They don't have sanitation. It's hurting everybody. If they could take water that would otherwise be needed for irrigation of farmland and possibly use it for people, that would solve one issue, but it means there's no food available. If genetically modified crops could compensate for that reduction in irrigation, they therefore have both food and better sanitation, or at least drinkable water. The issues aren't just limited to things like the farmer's ability to grow them domestically. The Kenyan government has banned them from being imported since 2012. This puts a strain on supply lines from international aid. For example, America, Canada, Brazil, and India all grow genetically modified crops in many cases. This is food that can't be imported to feed Kenyans because of that ban. That did change in 2022 when they finally allowed the farmers to start growing corn that had been genetically modified to be pest resistant. That was great news, but then, only just last month in February 2023, 4 different legal proceedings were started, and this prevented the distribution of that genetically modified corn, which would then have carry-on effects of giving some food security to Kenya. This is a big issue. The corn seeds need to be planted out very soon, as it's literally only the next month or 2 where they'll be able to do so. The rationale behind these lawsuits is, to be quite blunt, stupid. Admittedly, there's some leniency, but it is still stupid. The first argument is that the treaty in the area between different African countries has required that they protect natural resources. Okay. The second is that the availability of genetically modified crops would shift development away from indigenous crops, which, given that people are otherwise going to be starving, seems like a rather insidious argument and very disingenuous. After all, it's not going to help anybody if there's nobody to grow indigenous crops since they all starve to death. By no means are we saying that this is going to be a silver bullet that solves all of the food security issues. Drought will still be a problem. Plague proportions of locusts will still be a problem. The food will still need to be planted, but they can increase the yield per an acre or hectare of land that is being grown on. In this instance, genetically modified corn will produce just over 11% more per square meter or foot of land being grown on than it would with conventional crops. That 11% extra may not be much, but it adds up very quickly once you start scaling it to the amount of land that will be needed to substitute for the genetically modified crops, which will need to be cleared, fertilized, tilled, planted, and ultimately harvested. Going from Africa and the agricultural sector to a more global examination of salt flats. These are basically large areas of what were formerly lakes. Historically, the salt in the water has settled to the bottom as the water has evaporated off from the top. This has left behind a repeating pattern of hexagons, which is interesting and unusual. Just why exactly is it that everywhere you go where you find something like a salt flat, the same pattern occurs. After all, it's unlikely that they've simply dehydrated exactly the same way for no reason. Not only do you see it as a repeating pattern of hexagons, but that there's always a salt ridge giving you the outline of the shape and then the internal portion. There is some, at least, theoretical explanation, and it's a purely model-based understanding as to how and why it's occurring, and it is almost entirely driven by curiosity more than anything else. The simple explanation is that the salt is sitting there, but it's also partially in water. The water slowly evaporates off, and so this leaves you with the salt left behind, but not all of the water is being evaporated off. Some of it remains behind, and this becomes more salt-rich. That more salt-rich solution of water sinks, while the water that is less salt-rich rises to the surface. This means that the low salinity or low salt water is what gets evaporated first. The water continuously moves in this fashion where you go from the highest salt-rich water sinking to the bottom to the lowest salt-containing water rising to the top, and it always goes around in this circular manner. This leads to each individual pocket of salt-rich water creating its own hexagonal shape. The part of it where there is the most salt available is where the ridges will form, while the area where there is least salt-rich water is where the shallow or basin of each hexagon will form, and so it's arguable to say that what you're seeing is roughly the middle of each individual reaction is not actually in the middle of the circle, about a quarter in from the middle. The fact is that the entire process is a naturally occurring phenomena, and you can see it with, say, oil lamps, where the different density of the content causes the different contents within the oil lamp to move in a particular but repeatable fashion. In the same way, you see the same consistent pattern occurring in the form of a hexagon because you have the same consistent movement of salt-rich water. Going from the environment to archaeology and animal news and very, very large and disquieting ants. The ants are reasonably well described as being giant. They are about the size of a hummingbird, and hummingbirds are not small, somewhere around the size of 5 to 16 centimeters, depending on which direction you measure. The body from head to tail is 5 centimeters, and the wing to wing is 16 centimeters. So the rather disquieting sized ants are already worrying enough, but they also were hunters. They would eat anything that they could get their hands on that was, well, able to be killed and consumed by them, if they weren't able to access something more easily available, like for example the remains of an animal that had already been hunted or died from a more large predator. The reason why we don't see giant ants now appears to be driven by one simple factor. They needed a very hot environment, far hotter than the world currently is. As the temperature dropped, their ability to survive basically fell off a cliff. Because of this, and the fact that they can't make their own environments that are hot like a human would with a heater, they basically had no way to keep going, and so they had to shrink to keep going. Fossils of these giant ants have not just been found in Germany, but in South America and North America. Even today, the further you move towards the equator, the larger the ant species you will find. If ants were enough to worry you, and insects are never pleasant for the most part, we'll move across to arachnids, and notably spiders that are feeding on shrews. Yeah, this is not a desirable video topic for us. Spiders are pleasant always, not just most of the time. But watching a spider from the UK, which is where things get weird rather than Australia, eat a shrew, or basically a mouse, in a window is... yeah. This was likely not a particularly pleasant experience for the shrew before it died, let alone the process of. The spider in question has a rather nasty neurotoxic venom which causes neuromuscular paralysis. The shrew was also hoisted about 25 centimeters up into the web of the spider. After it was neatly stored away, the spider proceeded to feed on it for 3 days. What is disquieting about this is not so much that the spider is eating something significantly larger than itself, but rather this is the first example in the UK to occur. Other countries have observed this particular behavior before, although it might be more accurate to call it an adaptation rather than behavior, as the spiders seem to be, let's say, learning this new technique of finding food by using their various tools. Poison or toxins, in this case in the form of venom, their incredibly strong spider silk, and their ability to, well, feed on just about anything if they melt its insides. And the final news item we have for you is also environmental and animal related, but specifically orca whales, which strictly speaking are a dolphin, not a whale. Further to that, they killed 17 sharks in one event, a KDR of about 9-0. The pair of orcas are generally going to grow to somewhere around 5 to 7 meters in length. Each of the sharks they killed will grow to about 3 meters in length. As with other dolphin species, they were particularly vicious in what they did to these sharks. For example, several were missing their livers. There's also the contents of their stomach, which was devoured by the orcas. These are also not the only victims that these orcas are likely responsible for, as there have been a number of other species of shark, notably the great white sharks, that have appeared in a local bay, also missing their livers. This very much sounds like a pair of serial killers, but dolphins are already well known for their particularly antisocial behavior. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.